Hello everyone, welcome back. So in this video we are going to understand weekly contest 466. Okay, so the questions we have here is minimum operations to equalize array. Okay, so let's try to understand the question. So you are given an integer array that is called nums. Okay, that is nums means what we have given array, as you can see here, nums. Okay, so this is an array we have given. Perfect. So it is also saying in one operation, right? So there is a operations you have to choose any subarray, right? Any subarray you have to choose from left to right. This is the bound we can say. Okay, means in one operation we have to pick a subarray, contiguous part of the subarray. We can say subarray is a contiguous part of array. Okay, from left to right, this will be the left index and this will be the right index. Between that, inclusive of that, we have to take, right? So the left should be greater than equal to 0, and similarly for the right should be greater than equal to 0 and should be greater than equal to left, right? Means the right can be greater than equal to the left and should be less than n, means out of bound it should not go. Okay, so means both boundaries is between 0 to the n. Now it is saying replace the each element in the subarray with the bitwise AND. Okay, you know the bitwise AND. I have talked you multiple times. So we'll understand, don't worry. So we'll go through the bitwise AND also. Okay. So we have to replace each element in that subarray with the bitwise AND of all the elements. Okay, and then we have to return the minimum number of operations required to make all the elements equal to the nums, right? Means all the elements should be equal of the nums. We can say all the element of the nums should be equal. The subarray, it is a continuous non-sequence element of the array, we can say that, right? Means very first we can say in one operation we have to choose the subarray, right? We have to pick the subarray in the contiguous part of the array, we can say that, and we have to replace every element of that subarray with the bitwise and of all the elements, and our goal is to make all the elements is in the array in the array is equal, array elements is equal. So we will return the number of operations needed, right? In this week we have seen how to do that, so we'll understand how to implement it. Okay, multiple questions came into this week in the daily contest problem, right? So if you are following me, you know how to implement it. Okay, so without wasting time, let's continue. So you are in the contest, you can just try this piece of code and you can implement it. But if you want to understand, let's continue to understand. Very first, I'll go through the implementation in very slow down, right, way, so you can understand. Very first, the bitwise. Let's talk about first the bitwise AND. Okay, so what is bitwise AND? Think. Very first, we should before implementing it, we should understand the bitwise AND, because many of you may be a beginner, so I'm talking about in the perspective of that. Okay, if you're not, just take the code and you put into the lead code, you will understand. Okay, but let's try to understand what is bitwise AND. So bitwise AND, what is bitwise AND? The bitwise AND is it compares two integers, right? By how? By bit by bit. Can we say that? Means it's compare, what it does, it compares two integers, right? Two integers. Okay, how? By bit by bit. Okay, and so its operator we call is AND. That I think you know that. Okay, so very first, how we do that? What is the rule when we doing the comparison of two integer bit by bit in the binary form, right? We are talking about the binary form. So let's try to understand. Very first, the rules are, we have, let's suppose one bit we have, so one bit and one bit will be become what is 1. I hope you know. If we'll take 1 and 0, it should be what? 0. If this is 0 and this is 1, we call it 0. 0 and 0, it become 0. Okay, so in the digital electronics, it says if any of the bit is switch off, means it is 0, and any of this is 1, doesn't matters. These all will become 0. If both switches are on, in that case, the switch will be on. In that case, it called AND gate, right? From there, it came the bitwise. Means if all two bits are same, will return. In the case will return should be 1, means it should be switch on. Then only it will be 1. Otherwise, in other cases, if anywhere it is switch off, it will give you the 0. So this is very easy way to understand the bitwise. Okay. So each pair that contributes, we can say, results in 1 only if both bits are 1. I hope you understand. Okay. So now let's try to understand the example one. Okay. So in the example one, as you can see, what we have given, 1 and 2 we have given. What we have given? 1 and 2. So can I say that for the 1, if we'll represent, it will become what? Let me clean it. For 1, it will become what? In binary, 0 and 1, right? And for 2, it will become what? It in the binary, it will become 1 0. You know the rule, 8 4 2 1. So make 1, it will be 1, and for the 2 digit, it will be 0. So this is the case. For 2, it will become 1, this one, and this will become 0, right? So we have written this one. I hope you know these things because this is the basics. Okay. Now we have to compare bit by bit. So how we are going to compare? Just make AND, right? To make the AND, you know 1 0 is 0 and 0 1 is 0, right? Can we say that? So it becomes 0 0, which is what? Which is 0, right? So in the decimal, this number is 0 if we operate AND, right? So we can say for 1 and 2, it is nothing but a 0. Can we say that? Means if we are taking 1 and 2, it gives you 0. Okay, that we will understand. Okay, but for now, just think example is why giving 1, we'll talk about later. Okay, so now let's talk about how this has been used in our example. Okay, so when we choose a binary, right, let's say we'll call it A, B and C. Okay, A, B and C. Okay, if I'll take a subarray that chooses A, B and C, so there can be 3 elements, right? So when we compute it, and how will it look like? It become like, let me clean it. We'll say this, let's call and we'll say I want A, B and C. When we have A, B and C in a array, and we'll call this a subarray. So when we talk about subarray this, right, it means what? We are getting this value. Okay, let me increase this font a little bit. Okay, so I hope you understand, correct? So when we talk about and of the ABC subarray, we need to do like this, right? Then we will replace all the element of the subarray with a single value, right? Let's call, I'm talking about if we have nums we have 1 and 2 in example 1 here. So when we have, so let's pick very first subarray, right? I'll take all the element because there is only 2 elements. So I'll pick we'll call this is my sub array. Okay, this is my subarray, and subarray is 1 2 because there is 2 element. I'll take the whole element. Okay, so if we'll take 1 and 2, we know that this will give you 0. It means what? So nums is now what? Is 0 and 0. Okay, we know either we'll do these two values, we will get what? 0, right? So when we'll say is 0, means the nums now became is what? 0 0. It becomes, we can say, okay, 0 0. Now it's all equal. Understand? So why does choosing the entire array works, right? So if you take all the elements, right, like this we have done, right? So what will happen then after one operations, right? What is happening? Everything becomes equal immediately, right? And that is why The number of operations we have used is 1. How many number of operations we use? Only one operations. When operation is equal to 1, if you remember, I was talking like this in this daily contest problem in this week, right? So if operation is 1, we will return how many operations we have done. We have done 1 and we'll return it. Okay, that is why the solution is, when we talk about 0 operations, if already equal, will means we should understand why the solution works, right? Because if 0 means what? No operations have done, means operation is already operation is 0 if already equal, right? Let's suppose very first the array is given is 1 1, means it's already 1 1, so we are not doing anything. In that case we'll get what? 0. But if the value is there, if we will change something that, and we will apply the rules like this, right? It means we are operating the and we are making the equal. In that case there will be some value we need to do, means the operation will be 1 otherwise cases, right? If it is not already equal. I hope you understand what I'm trying to say, but for now you try to understand. This is the concept behind the problem, right? And you should able to understand. Okay, so for the implementation purpose, what we need to do, very first we know that this is our array, right? We can say our length we will find, right? And we'll check if the n is less than 1, right? We'll return 0, because there is if n is less than equal to 1, means only one element there, so we'll no need to do anything, it's already equal. So we'll return the operation 0 if already equal, means it is a 0, means let's suppose I'm typing if there is 0 element, right? If there is one element is there, like either this element or any number element is there, means there is how many elements is there? It is what? It is already one element, right? So we'll say less than equal to, we'll say return 0. We are not doing any operations, right? For 0 means it's already equal. Otherwise if you are making any changes, we'll say return 1, or any number of operations, we can say number of operations will return. I hope you understand. Okay, now let's talk about that. We have talked about this one. Now what we have? Int n, int I will start from 1 and we'll go to the n, and we'll check the consecutive elements, right? If consecutive elements are what is not equal to 0, will return what? Will return 1, and in else condition will return 0. Okay, so this is what we need to do, and I hope you understand. Okay, thank you for watching this video. I'll see you in the next one.